Hi there, my name is Scott Westover, and welcome to my course on Introduction to GitHub Actions. In this mini-course, you'll be learning about GitHub Actions and GitHub Workflows. The goal of this course is to provide you a brief introduction to GitHub Actions, how they function, and why you should care about GitHub Actions. Throughout the course, you'll be introduced to various CI/CD workflows that you can take and use on a daily basis. In this course, we will be covering the following topics. We'll be going over GitHub Workflows and Actions. We'll be covering what these terms mean, how the GitHub Actions platform can be used to improve your CI/CD workflows, the core concepts of GitHub Actions. We'll be going over the workflow files and what the syntax of these workflow files is in these YAML files, how GitHub uses these files to run your various workflows, and the directory it expects those files to be in for everything to function. We'll be doing a brief project setup so you can follow along with the code in this course. We'll be taking a look at the GitHub Actions Marketplace and how you can search for other actions to reuse in your workflows. We will be taking a look at how we can create our own workflows, such as integration test, tagging and versioning a project on GitHub, publishing an NPM package, pull request workflows for linting, testing, and building your application code. And we'll be looking at the various triggers that we can use to trigger these types of workflows, and we'll be providing you the code and reviewing how they all function. For this course, we have the following basic requirements. It is required that you'll have a GitHub account. This is required for using GitHub Actions and for creating repositories, both public and private, in GitHub. It can be a free account. There's no charge. You don't need to have a paid account to follow along with this course. You will need to have some background knowledge in Git. This course will not be covering what Git is, what Git flows are, how to set up Git, etc. The course already assumes that you have some of this knowledge. Finally, you're going to need a text editor or an IDE for editing the course files. This could be any editor you choose, such as IntelliJ, WebStorm, Notepad, Notepad++, VS Code, etc. And finally, for this course, I will be using VS Code as my IDE. This is not a requirement for this course, but here's a link in case you need an editor and would like to try out VS Code. All right, let's get started. So before we get started, we're going to take a look at what GitHub Actions is and why you should care about GitHub Actions and GitHub Workflows. So what is GitHub Actions? So at the end of the day, GitHub Actions is a CI/CD platform that allows you to automate your build, test, and deployment pipelines. And if you're not familiar with CI/CD, this stands for Continuous Integration and Continuous Deployment. And this is a software development practice that combines development and operation teams in their day-to-day task. And this applies to the automation of developing, testing, and delivering your application. And so what that really means is there's two pieces here. There's continuous integration and there is continuous deployment. And they are two separate things, and CI/CD is kind of combining both of these things. So if you're not familiar, continuous integration, or CI, is the process where teams integrate their code early and often into one central location. So in the case of our course, this will be GitHub, but this could be any platform. Like I said, the key concept is you're integrating it into one spot. And the goal of this is to speed up your release process by enabling your team to identify and fix your problems early in the development cycle. So instead of waiting until a feature is completed, you can start doing incremental releases to start doing your testing. This continuous integration reduces the amount of time you spend on bug fixes and regression testing and helps ensure that everyone has a deep understanding of what's really happening in the code base and what features they're developing for your end-to-end users. On the other end of the spectrum, we have CD, or continuous delivery, and this is the practice of getting all updates, fixes, features, and configuration changes either into production or into the hands of your end-to-end users as quickly and safely as possible. And really the main goal here is you want to streamline that delivery and deployment process so that your repeatable and predictable task can be performed on demand. And so this goes beyond just deploying production code as well. This could also be like a development environment or a test environment where you're testing your changes and doing integration tests before you actually hit that release button and promote it to production. And this is kind of one of the workflows we're going to take a look at is, as you know, when code is pushed, we can release a new version, which then later on could be used to kick off a deployment process. And so some examples of this is, let's say if you have a static website, you could have your continuous deployment build and then deploy that site to your environment, like Heroku, S3, so on, GitHub Pages. An example of continuous integration could be where you want to run your linting, you want to run your tests every time there's a new change pushed to your repository. Some other examples of CI/CD platforms are like Jenkins, Travis CI, and Circle CI, and these all have integrations with GitHub as well through GitHub Apps. And so this is all built into GitHub in your GitHub repository. So now you can manage all of this from one location. So why should you care about GitHub Actions? GitHub Actions are fully integrated into GitHub, and you are not reliant on another tool. So like I mentioned, there are other platforms and tools that can do the same functionality, but these are all built into GitHub, and so you can manage it all from one spot. You're also not reliant if there's an issue with Travis CI, you're not blocked from deploying something. What's great is there is a free plan for everyone. So if you have your code hosted on a public open source repository, GitHub Actions is free. You don't have to pay for a subscription, you don't have to pay for any of the plans, it's just free out of the box. And if you have a private repository, you get 2,000 free minutes per month that you can use for GitHub Actions. There's a large collection of CI templates that you can automatically use when you start a new repo and you want to set up GitHub Actions. There's also a GitHub Marketplace, so there's a lot of reusable third-party actions that you can use out of the box. Some of these include things like checking out a repository, deploying code to NPM, and many, many more. So now we're going to do a brief overview of what the core concepts are for GitHub Actions, and we're going to talk about some of the key terms. So in GitHub Actions, the main components and key concepts are workflows, events, jobs, actions, steps, and runners. And all these terms are tied together for your GitHub action and workflow. So a workflow is basically the overall process that you want to run when something occurs. Your workflow basically encapsulates everything here that's shown in this image. Your workflow is a configurable automated process that can run one or more jobs. It is defined in a YAML file that's checked into your repository, and it will be triggered when particular events happen. Or they can be triggered automatically at a defined schedule or manually. So basically, like I said, the workflow is the whole process that we're going to run. Your workflow could be, let's say when code, a pull request is opened, you might want to run some tests, lint your code, try to deploy and build the files. That could be one whole workflow. You could have a workflow that could be automated every day, and it runs white source scans to check for vulnerabilities. So how workflows are triggered is it's triggered by an event. Your events can be a GitHub event, so such as like a pull request being opened. It could be an issue being created, code being merged. It could be a manual trigger event, or it could be automated. Like I said, it could be a daily cron job that runs. And so inside your workflow, you define your triggers, which are tied to these events. And so GitHub will check your triggers when these events happen and then kick off your workflow. So then inside your workflow, you will define your jobs. And so basically your jobs are something that you want to happen. One job, like I said, could be building your application, and another job could be deploying it, so that way you can encapsulate it. And basically these jobs are going to run on what is called a runner. And so your runner is basically a container that could be Ubuntu, Windows, Mac, OS. It could be your own hosted runner. And so basically this is where your code is going to be run and executed. Like I said, it uses an operating system, so that way you can install dependencies that you need to run various tasks. It's going to be your virtual machine. So inside your job, you can define a set of steps, which is basically the steps that you want to run when a particular thing happens. So your steps can be executable scripts, or they can reference other GitHub actions that are small, reusable components that are repeatable that you want to execute in your script. So just as an example, like if we have a workflow tied to a pull request, maybe we want to check out the repo as step 1, and that could be a GitHub action. Step 2, we want to go ahead and set up our dependencies. So let's say we have a node project, we would go ahead and install node, install npm, so that we can install any dependencies. So that would be a couple steps. That'd be like steps 2, 3, and 4. And then let's say if we want to run linting or test, those could be our next steps. And so at a high level, these are the key concepts that are important to GitHub Actions. And what we'll see in the coming videos is as we're setting up our workflows, we'll see how these concepts tie to our workflow file and what they actually do. All right, so before we get started, the first thing we need to do is we need to set up our GitHub repository that will allow us to run and execute our GitHub workflows and actions. And so the easiest way to do this is we're going to fork the course repository, and that's going to basically give you access to all of the code that's here, as well as the various branches that have been set up. So in the description of the video, there's a link to this repository. And in the repo, we're going to see the main branch, which is going to have the completed code for the course, as well as various other branches that are tied to different particular parts of the lessons. And there will be a start and end, so that way if you're interested in one particular lesson, you can go ahead and check out the code from that point and work from there. Or as you're working through the course content, if you need to compare what you have with what we finished with at the end of the lesson, you can do that as well without having to dig through everything that was done overall. And so, like I said, there's a few different ways you can do this, but the easiest way we're going to do is we're just going to go ahead and fork the repo. I'm going to go ahead and choose your user or organization if you prefer. And what this will do is Git will create a complete fork of the repo, which will include all of the commits, it will include all of the branches, and everything's been done so far. And once you do that, you just need to go ahead and have a way to work on the code. So generally, you go ahead and clone the repo, pull it down, work on it locally. You can use the GitHub IDE to edit the files, whichever you're most comfortable with. All right, and once you check out the code, the main branch we're going to want to focus on is going to be 0 course start, or if you're going right into hello world, you can do hello world start. And basically, it's going to give you a pretty bare bones repo just with a README and a license. All right, so now that you have your repo set up, we're going to go ahead and create our first workflow. So for our first workflow, we're just going to do a basic hello world example. And the goal of this workflow is just to introduce you to the folder structure that you need for your workflows, as well as just show you how to set up the basic syntax and how we can go ahead and execute and view the results of our actions in the GitHub UI. And so for GitHub workflows to work, GitHub expects your workflow files to be defined in a particular folder structure. And if your YAML files for your workflows are not in this folder structure, GitHub will not recognize them. You won't be able to execute them. And so as an example, if we go to our Actions tab in the GitHub UI, you'll see that there is no GitHub workflows currently set up on our repository. And so to set up our first workflow, what we're going to do is we're going to go ahead and go to our IDE, and we're going to set up that folder structure. So GitHub expects a .github folder, and inside this folder, a subfolder called Workflows. And now, so the syntax for your workflow files is going to be YAML. So we're just going to go ahead and create a new file, and we're going to call it Hello World YAML. All right, and so now for our workflow file, there's a few basic components that you always have to have defined for your workflow file to be recognized by GitHub and to be executable. And so the first piece is the name of your workflow. So this is what's going to be shown in the GitHub UI. And so we're just going to call it Hello World. And then the next one is your trigger. And so this is defined by the on keyword. And so your trigger is what is going to be the actionable item to make this workflow run. There's various different, there are a variety of triggers that can be used for your workflow files. You can use GitHub events. So this includes things like pull request, merging into a particular branch. You can target particular files. You can ignore certain files when changes are made. You can do a workflow dispatch, which is a manual trigger. So you can manually trigger this workflow. You can do a cron-like expression, so it'll run periodically. And what's really nice is you can do a combination of these. So if you want to support a cron, a manual trigger, a pull request, you can define all these different triggers for your workflow. As for our hello world, we're just going to do a workflow dispatch. And basically, this is going to enable the GitHub UI for us to run this workflow manually. And so the last component we need to define is going to be our jobs. So if you remember, a GitHub workflow is made up of one or many jobs, and your jobs are going to be what is executed when this workflow runs. So you can just think of your job as the overall piece, the overall component that will be executed. Then inside your job, you can define multiple things that you want to happen when it runs. And so we need to provide a name for our job. So we're just going to say print hello world. And then for your job, you need to define the runtime that will be ran when your code is executed. So this is going to be like your operating system. So it could be like Ubuntu, and you could define your version. So you could do like latest, or you could pin it to a specific version. You could, if you're doing like Mac specific builds, you could do a Mac operating system. So you have the tools you need when this runs. So this is defined by runs on. Ubuntu latest. And then you need to define your steps. So these are the actionable items that'll run and that we define. So we just do steps. And then so each step will generally have like a name, an ID, run if you're executing particular commands. If you're using third-party GitHub Actions, you would say uses. You can use the with keyword to include environment variables or variables to the third-party action for each step. So what we're going to do is we're going to do a name. Just going to call it say hello, and then we're going to do run, and we're just going to go ahead and execute echo hello world. And we'll go ahead and save. All right. Oh, and before we push our code, we just need to fix our folder name. So we're just going to change this to workflows. And then what we just need to do is commit our code and push it up to the repository. All right. So now that we've committed our code, we'll come back to the GitHub UI. And so if you refresh the page, you should see your GitHub Workflows file, folders with your Hello World YAML file. And so if you come to the Actions tab, you should see now the workflows defined here for your repository. And so one thing to note is your view may be different than what you see on my screen here. And the reasons for that is GitHub on the Actions tab will detect any of the workflows that exist in your main branch and any workflows that you've run previously before. So in the main branch, we have all of the completed workflow files, so that's why they're showing up here. And so what you'll want to do is go ahead and click on Hello World, so that's the workflow we just worked on, and you'll want to go ahead and execute the code from there. If you are working from like the Hello World start or in branches or the course start, and that's where you committed your code, you'll want to make sure you target that branch when you execute. And what GitHub should do is it should recognize that file exists and allow you to execute it from that branch. As an example, if we go to start here, you'll see it doesn't exist, but on the end it does. So now we can run that workflow. All right, so if we go ahead and click on Hello World, what we're going to do is we're going to go ahead and click on Run Workflow. And what this will do, this is going to go ahead and queue up our workflow to run on the public GitHub runners. So we got to wait for GitHub to have an available task to go ahead and take and execute our code. And so you'll see here, it went ahead and executed. So we can go ahead and click on our workflow to view the results. So here on the summary page, we're going to see the jobs that were executed. So remember, we only have the one, the print hello world. So if we click on the job, we can view the details of what was done. And so GitHub will always have two steps that are included in all jobs that are run. One is the setup, and the other one's the teardown, so the completing of the job. So the setup will go ahead and install like the operating system, so Ubuntu, the latest at this time, and set up your virtual environment, GitHub token, and prepare everything to go. And then it'll start executing your steps. So for our steps, we only had run echo hello world, and so you'll see it executed that code. And so we see hello world. And then the cleanup will go ahead and clean up any remaining items from the job. All right, and you just created your first GitHub workflow. All right, so now that we've set up our first workflow, the hello world, we're going to start looking into some more complex examples. So before we dive in to our next workflow for the cron example, what we're going to do is we're going to talk about the GitHub Marketplace for actions and using shared actions in your workflow. And so for our branch, we'll be using the to shared actions start. And in here, you're going to see a cron example project. So we're not going to dive into that right now, but we're going to want the subfolder just as an example. We'll dig into that further when we do the cron workflow. And so circling back to the GitHub Marketplace, one of the most powerful things about GitHub Workflows is you have the ability to use other actions that have already been created that are small components that do some type of functionality inside your GitHub workflow. And so this is important because there's a lot of things that have already been set up for you that you can take and use in your workflow without you having to go through and write the code and do so. So what we're looking at now is the marketplace here that's showing all of the published actions that are available today. And all these actions, we have the option to use these in our workflows. So just an example, we have the setup node JS environment. If we click on it, what this will do is it'll take us to this GitHub action and the particular latest version. It'll have the README of how this works. Generally a link to the GitHub repo, so if you want to help contribute to it, you can. And this is a great example because let's say in our project that where we want to do our cron example for integration test, and it's a node project, because in our workflow, if you remember, all we're specifying right now is this runs on, and we're using Ubuntu. And so we get the base image of Ubuntu, and if there's any additional tooling or any other setup that we need, we have to manually tell that to the container of the job that we want those particular tools. And so let's say if we have a node project. If we have a node project, the first thing we want to do is we're going to have to check out the repository that our code's in so we can run something against it. So let's say if we have a static like React UI, we need to build the UI so that we can push it to wherever we're hosting it. And a workflow could do this, but we'd have to have access to check out the repo. And you know, if it's React, we're using Node for our dependencies, and so we'll have to have Node installed. Then that way we can use NPM to do our installing of the dependencies, run our scripts for our commands, and so on and so forth. And you can see, building out this workflow that we would do locally, we need to specify all those steps and how we're going to go about doing that. And this is where the marketplace comes in. So instead of us having to write code to, you know, clone our repository, check out a particular branch, install Node, install Yarn, install any other tools that we need, we can use these third-party actions that already have the code to do this. So like this action here, you know, it'll set up the Node environment for us. We can specify the particular Node version, and to use it, it's just a few lines of code in our workflow instead of us having to, you know, go to the Node website, download this particular version, go ahead and extract the tar, and now make sure NPM is available. This action will do all that for us, and we only need these few lines of code. So this is where workflows are really powerful, because you can also create your own actions and share them with the community, and it makes them very reusable, and you can make them very small components, so they're very easily testable. So what we're going to focus on here is we're going to just work on checking out our repository and our workflow, and just checking what files are available to make sure that we actually checked out our repo. So this is just going to be like a easy introduction to how these third-party actions work. All right, so what we'll do is we'll go back to our IDE, and what we're going to do is we're going to go ahead and create a new workflow file. So what we'll do is we'll do a new workflow file, and we're just going to call this shared actions.yaml. And what we're going to do is we're just going to copy the code from our Hello World YAML into shared actions, just kind of some boilerplate. We're going to update our name to be shared actions example. We'll keep our workflow dispatch, so we'll run this manually. We'll go ahead and update our job name. Let's do checkout repo. We'll stay with Ubuntu, and then we're going to go ahead and update our steps. So for our steps, what we're going to want to do is we're going to use the checkout action to check out our repository. So to do that, you have to use a particular keyword, uses. And so when GitHub sees this keyword, it will know to go into the marketplace and look for an action with this name. And generally, this will be a organization or username first, followed by the repo name. So in our examples, it's going to be actions, and it's going to be checkout, and we're going to do @v2. And so what the @ does is allows us to specify a particular version that we want to install of this action. And so in theory, we could leave this as action/checkout. And what this will do is GitHub will download and install the latest version of this action, which is great. However, if there's ever any breaking changes, or if someone introduces a bug into the main branch and it gets released, then we're going to check out that broken version. So it's very important when you're doing your workflows, if you do rely on third-party actions, that you pin to a particular version that you know that works. So this could be a release version, it could be a particular branch, it could be a commit SHA, so that it's tied to that particular commit. So you can be very explicit on which part you want to check out. And so the other part of third-party actions is you can also provide parameters to them. And so generally it would be, we do like with, and then we could provide additional variables to pass as input. So if we go back to the example, you'll see in the README that if we look for checkout, you'll see we have the official GitHub action for checking out our repo. You'll see it supports all kinds of parameters, so like repository, a particular Git reference, if you need a GitHub token, if it's like a private repo, and many, many more options for checking out the repository. And so by default, if we don't provide any of these, our workflow is going to check out the repository that the workflow is running in. So in our case, it's going to check out our own repo for the branch that we are running the workflow on. So it'll be our main branch or the particular sub branch if you're using that. All right, so we've come back to the IDE. So in our case, we don't need to specify any additional parameters because we have a public repo and we're checking out the repo that we're working in. And the last thing we're going to do is we're just going to do a run and we're going to do an ls. And this is going to list the files or directories that are available in our repository after we do the checkout. All right, so now we're just going to go ahead and commit our code and push it up to GitHub. All right, so now if we go ahead and go back to our repository, if we go to the Actions tab, we should see our new workflow. So if we go to Shared Actions example, what we're going to do is going to go ahead and run our workflow from the branch that we pushed to. All right, so once our workflow completes, we'll go ahead and go into it, and we'll go ahead and take a look. So if we go into our checkout repo job, what we'll see is we'll see our two steps we talked about before. So we go ahead and set up our repo, and so there's some new additional things. So you'll see here we're downloading the action for checking out our repo. And so what GitHub does as part of the setups job is if there's any third-party actions you're using, GitHub at this point will go ahead and try to download those and that particular version and make sure they're accessible before it starts running anything. So it does that as part of this setup job. And then if there's any cleanup steps defined inside that action, so as you'll see here, we'll go ahead and run those steps to do some additional cleanup. before we complete our job and clean up our other processes. So this is just important to note, because if we reference an invalid third-party action, our workflow will fail, or if we reference a version that is no longer available, it'll also fail as well. So if we go to the step for running the checkout, you'll see here we're running our actions checkout v2, and then what's happening is it's all those parameters that we looked at. There are default availables that you could do on your action, and so you'll see here we used our repository that we're pushing our code to. It's using our GitHub token that's tied to this repo when this CI process runs, and it's using some additional things like SSH strict, fetch depth 1, LFS submodule set to false, and so you got to be mindful of any of these actions that you use. Some parameters will have default values, and you just want to double check that they're set to what you want them to be. And in our case, this is exactly what we want. So then you'll see here now it's running the code that's tied to that action. So like it's grabbing Git, it's initializing a repo, it's going to go ahead and set up the auth, it's going to fetch the repository, check out the branch depending on what was referenced here. And so now you'll see we're tied to our main branch since this is where we ran the code. So then we go ahead and execute our next step. So what all we do is did the ls, and so we'll see we have our license file, our readme, and then our cron example subfolder. So you see here we actually did check out our code and we made it available inside our container. And so you see this is one small example of how we can use a third-party action that's reusable across shared workflows, and how we can start to build these very complex workflows by making use of some of these actions that are available in the marketplace. So then that way we can, build these workflows fast without having to write everything ourselves. All right, so now that we've seen how we could use actions from the GitHub Actions marketplace in our workflows, we're going to start building out some more complex workflows in some examples that you may actually use in your day-to-day. So our first workflow we're going to take a look at is building a workflow that will allow us to run integration tests against an API. So you imagine you're building an API as you deploy to your various environments. You might want to be able to execute integration tests at any point in time, maybe after you merge new code, maybe you want to run in a cron, so like every 12 hours you're just validating that your API is still responding correctly after changes are made. So there's various use cases for doing this, and so in our particular example we're going to set it up as a cron, so it'll be running every 5 minutes just to hit our API, make sure everything's still working, and we'll set up with a manual trigger so that way we can execute it anytime we want. And so for our particular example, in our 3 cron example start branch, you'll see there's that cron example subfolder. So for this particular workflow, we'll be using this folder quite a bit. So in here is just some background. What this is a node project that basically uses Cucumber.js and Pactum.js to execute an integration test against API endpoint in HTTP pastebin. So because it's a node project, we'll have our package JSON. If you're not familiar with a node, package JSON just allows us to provide some metadata about our project as well as the dependencies and scripts that we want to execute. So you see in our dependencies, we require Cucumber and Pactum to run our code. If we step back, our yarn lock file, if you're not familiar with yarn, it's similar to the package JSON lock where it just pins our dependencies, and so that if we do an install, we have repeatable builds because we're using these particular versions. And then inside the features folder, this now has code that's tied to both Pactum.js and Cucumber.js. So we have this feature. So basically we describe a feature of what we want to do. So in this example test here, we're making a GET request to this particular endpoint, and we expect a response to come back with 418. And then basically we have our step definitions, which refers to that file and what we want to execute when those things happen. And so this course isn't about Cucumber or Pactum.js. They're both interesting tools. This is just an example project for executing a workflow and showing how that can function. So if you're interested, you can check out the links to the projects here. Otherwise, we're going to go ahead and go back to the workflow. All right, so to get started, what we'll do is we're going to go ahead and jump over to our IDE. And what we're going to do is we're going to make a new workflow file. So we're just going to call this cron.yaml. What we'll do is we're just going to copy the syntax from our shared actions. We're going to paste it over here, and we're going to update some of our values. So for our name, we're going to do cron example. For our triggers, we're going to go ahead and just leave this with workflow dispatch, and we'll come back and see how we can add a trigger for doing the cron type expression that we're looking to do. The reason for this is it's a little bit easier to build our workflow out and make sure it runs correctly on how we want to do if we have a manual process before we worry about that additional functionality. So we'll just go ahead and leave this with a manual trigger. And so for our jobs now, we're going to go ahead and update this to be run integration test. So usually what I do when I'm building a workflow is first I go ahead and see what steps I need to do to manually do the workflow I'm looking to do. And then from there, I can go ahead and take those notes and translate them into a workflow, and then go ahead and build out the various steps to make that actionable. So we're going to go ahead and try that now. So for our particular example that we're looking to do here, we want to run our integration tests that are tied to this particular project here, our cron example. And so the first thing we would need is we need our code available to us. And we get that by, as we learn, using the actions checkout shared action. This will go ahead and check out our repository. And so we'll have all these files available. So we already have that step completed. Our next step is we're going to need Node available in our environment in order to run our Node project. So to install our dependencies, run our scripts, and various things like that. So what I'm going to do, I'm just going to add a node. So we're going to set up Node. So typically if you're working on a Node project, you have it locally, but that's not repeatable. So we're going to want our workflow to be repeatable by installing Node. The next thing we're going to do is for our particular project, we are using Yarn. And so when we install Node, we get NPM available to us, and we could use that. However, as an example, we're going to go ahead and install Yarn on our machine so we can run that in a workflow. So we'll go ahead and install Yarn. So then for the project, before we can do anything, we need to install the dependencies for the project so we have all of the libraries we need. And so we would do this by using npm install, or in our case, yarn install. And then finally, once we have our dependencies, what we need to do is we need to execute Cucumber. And so we do that by referencing the Cucumber.js library, and we happen to have a script already set up for this. We just need to actually run our test script inside our package JSON. And so to do that, we just need to run our test. And so in theory, we should be able to run these steps in our workflow and execute our test. So to do that, first thing we want to do is go ahead and set up Node. So there is an action to do this. So what we'll do is we're just going to add a name. And we're just going to say setup node JS 12. So for our example project, we're referencing node 12. So we'll do uses. And so we're going to use actions. And we're going to do setup node, and we'll do @v1. And so this particular action expects us to provide the node version that we want to install in our environment. So this is done through this parameter. So we have node version, and let's do 12.x. And so what this will do is it'll go and download the latest version of Node 12 and install that and make that available in the environment. And so if we did a node -- version, it should output 12 dot something in our workflow file. And so this parameter allows us to be very specific on our version, or we could keep it open where we have the major version 12, and then we could have the minor like this. All right, and then so now we've set up Node. We need to go ahead and install Yarn. So to do that, we'll go ahead and add a name. We'll do install Yarn. And so now we'll do run, and we'll do npm install global yarn. So this is one of the ways that you can install yarn on your machine. So we'll be using that method. And then for installing your dependencies, we'll have our name. We'll do install dependencies. Do our run command. We'll do a yarn install frozen lock file. And so similar to NPM, if you have a package lock, in our case it'll be a yarn lock for yarn, if you pass this command, it's going to install the exact dependency versions that are defined in here. So we just want to make sure we pass that so it's repeatable. And then finally for our test, we'll do name, first we'll do run, test, run, and we'll do yarn test. All right, so one last thing we need to do before we test our workflow is we need to update the context of where we're running our commands. And so what I mean by that is for the scope of this workflow, we've been working under the assumption that cron example is our project and that this is what we want to execute everything against, which makes sense because if this was my project, I would go ahead and just run yarn install to install my dependencies. I would do yarn test to go ahead and execute this test script, and everything should work. However, this is a subfolder in this main repository here. And so what that means is for our context is the root of our repo is actually the context we're running everything against. So when we check out our repository, if you remember, we saw that we had our license file, our readme, and our cron example folder. And then that is the root of our context and where we're executing everything. So, if we check out our repo right now, we'll get all these files. We'll set up node. We'll have node available here. But then once we go to run these commands, we're going to run into an issue. And basically, when we go to do our yarn install, there's going to be no yarn lock or package JSON. So we're not going to install any dependencies because it's looking for it at the root of our repo. And so really what we would need to do is actually run these commands against this subfolder. So, we could cd into this folder and then execute the commands inside here. We could pass in the exact path when we run these commands. However, this can get very messy if we are building very complex workflows that are doing multiple things inside that one folder. And so another option that's available to us is we can update our working directory of where we want our commands to be run for a particular job. And so to do that, what we can do is we can provide a keyword called defaults with a keyword called run. And then we'll do working directory. And then we can specify the directory that we want to run our commands inside of. And so this will be the context for this particular job. And so what defaults is used for is it's a way to create a map of default settings that you want to apply to all jobs in a workflow or all steps, depending on where you place this. So, if this was outside jobs, we could apply it to every single job that runs, or if it's in a particular job, it only affects this one. And so by providing .run, we can provide things like the default shell that we want to execute commands, bash versus shell, or we can provide our working directory so that we can specify which directory in our repo that we want to reference. So actually the directory in our, our job, and because we checked out the repo, it exists. And so basically now when we do our yarn install lock file, it's from this directory, so it'll find the files we're looking for. So now that we've made that change, if we go ahead and commit our changes and push them up to the repo, all right, so now we've pushed our code. If we go ahead and go back to the GitHub UI, if we go to the Actions tab, we should see our new workflows. We have our cron example. Go ahead and execute our workflow. All right, so now that our job's complete, we'll go ahead and click on our workflow, click on our job, and so you'll see we have our setup job. We do our checkout. We go ahead and do our setup Node.js. So this will go ahead and use the particular version we provided. So you see we installed Node, and we can see our versions. We have 12.22, and we install NPM as part of Node, so we have 6, 14, 16. So then we have our custom command that we wrote for installing Yarn. So you see that we went ahead and add Yarn to our global NPM packages. So now we can use it. We went ahead and installed our dependencies. So you see we're using Yarn version 1.22. We're grabbing our packages, we're linking and we're building, and then we're done. And then we go ahead and execute our test. And so you see here for our test, we have our test file. Basically, it's only doing one thing. It's making that API request to that one endpoint. And we got the response back that we're looking for. So you see here it passed. And then we do our checkout and our cleanups. All right, so our workflow is working really good. We've seen that it does work. So our last component is going to be the cron-like expressions. All right, so to add a schedule trigger, basically what we need to do is we'll come back to our IDE, and what we'll do is we're going to go ahead and update our triggers. So as I mentioned before, you can have multiple triggers defined for your workflow. So for a cron, we need to do on schedule. And then for schedule, we need to specify cron. And then we need to specify the cron expression that will be used for evaluating when this should run. All right, for our expression, I'm just going to do 5 asterisks. And what this is going to do is it's going to basically, normally it would have a cron job run every minute, but GitHub uses this to run it about every 5 minutes. So a few things to note is this is not a guarantee that it will run every 5 minutes. It's just GitHub will try to schedule this and try to run it every 5 minutes. A similar pattern if you're trying to target a specific time, because GitHub has to, listen for that event, schedule this job, and then kick it off, run it. It's not a guarantee that it will run. All right, and then so if we go ahead and add and commit our changes, we go ahead and get to the GitHub UI, and we'll go ahead and see if our workflow will trigger. So this might take a little bit, so I might want to pause the video and come back to it, or we can check on it later. So if we go to the GitHub UI, and if we go to our actions, we go to our cron example, you'll see that after a while, we'll have a few runs that are triggered by a schedule. And so the schedule, that just means it was triggered because of the cron expression we did, and the event was the scheduled event. And if we go into it, we should see the same results where our tests were run and they passed. Otherwise, if they would have failed, we would have seen an error. So one thing to note is this is going to continuously run. So I recommend that you go ahead and comment out the section we just added. So then that way, if you keep a repository up, this isn't just constantly running all the time, using some of your limited workflows that can run, then be triggered, or if you're a private repo, so it's not wasting your minutes. All right, so in our next example, we're going to go ahead and build off some of the foundation we started to put together in our cron workflow. And the next one we're going to target is a pull request type workflow. And the idea here is that as people open up pull requests into your repository, there may be a set of actions that you want to run before you take a look at the code, before the code gets auto-merged, and a variety of things like that. Some of these things could include, let's say, if you have linting set up on your repository, you have a code formatter that you want to enforce rules and styling in the repository, you could run that check. Let's say you have unit or integration tests and you want to make sure that any code submitted doesn't break any existing functionality. You could run those tests as part of the pull request review. If your code is compiled, so let's say if we have a TypeScript project and we convert it to JavaScript, we could run that step here just to make sure everything is working correctly. So the event we're going to be taking a look at is the pull request event, and this event will fire anytime there is a new pull request that's opened in your repository. And so we can use that to trigger our workflow to then check out our repository and run the set of steps that we described. So for this example, there's going to be a project called TypeScript project inside a repository. So just some background here. This is a simple bare bones project that basally uses Snowpack to set up a dev server and to render out an HTML page, which then references a JavaScript file. And basically our JavaScript file is a TypeScript file that we need to compile, and then that way it's in raw JavaScript. Besides that, the rest of this is all boilerplate for the project. We're not going to dive into it. Those are the main pieces that we need to be aware of. All right, so now we're going to go ahead and jump over to our code. And so for our new workflow, what we'll do is we're going to go ahead and add a new file. Let's just call this pull request YAML. And then what we'll do is we're just going to come to our cron file. Let's copy the code we have in there, and we're going to go ahead and paste it over. And then, so first what we'll do is we'll go ahead and update the name of our workflow. So we'll just call this pull request example. So for our trigger, we'll go ahead and get rid of our cron, and we'll just leave it for workflow dispatch, and we'll come back and we'll test it after we have everything working correctly. For our job name, let's go ahead and make this a little more meaningful. We'll do pull request. All right, we're going to leave it in Ubuntu. So for our working directory, we want to change from cron example to our TypeScript project. We want to go ahead and check out the repository. So for this project, we're actually going to use Node 16. So we're going to go ahead and update our Node version. And then what we're also going to do is we're going to bump the setup node to v2. And one of the benefits of doing that is there is caching built into the version 2 of this action. And so what we can do is we can pass this cache key, and we're going to want to use NPM as our package manager. So what this will do is between jobs, it will go ahead and cache our NPM packages for us, so that when we do our install process, we're not always grabbing a fresh set of packages, and this will shorten the amount of time that it takes to run this particular workflow. And this is nice because if there's a lot of pull requests coming in, they can just make these auto CI checks a lot faster. All right, so we'll need to install Yarn, so the project uses it. We'll install our dependencies, and then we'll go ahead and run test. But what we'll do is before we run our test, we're going to add a few other additional steps. So two of the things I mentioned is I want to add linting, and I also want to make sure our code can actually compile. So we will go ahead and add those steps. So we'll do run linting. So we'll do a name, do run linting, and we will run our lint command from our package JSON. So we'll just do yarn lint. And then we want to go ahead and compile the code. So we'll have a name. And we'll just do build project. We'll do run yarn build. Perfect. All right, so if we go ahead and push our code changes, we should be able to test our workflow and make sure it's working correctly. All right, so if we go ahead and go back to the GitHub UI, we'll test our changes. So what we'll do is we'll go to the Actions tab. We'll go ahead and go to our pull request example workflow. If we click run our workflow to run it manually, it should kick off the job. And we'll go ahead and let that run, and then we'll check the status of it. All right, so if we go ahead and click on our job, we'll go ahead and take a look at the results. So we went ahead and passed. So we're going to a pull request. You'll see we're doing our steps we've done before. Then we run our linting command. We'll see that the linting came back successful. It builds our project. And since there's no test, it goes ahead and just runs the skip command, and everything's all good there. All right, so next what we're going to do is we're going to go ahead and actually update our event for our trigger. So as I mentioned, for our trigger is going to be our pull request event. So to use that, we're just going to do pull request like that. So with the pull request trigger, we can be as generic as we want to be. So we could have this run against all pull requests on our repository. We could target a specific branch, so like the main branch of our repo, so it'll only run for pull requests into that particular branch. We could also ignore certain branches, so that way it runs on all of them but the ones we exclude. For example, we're just going to go ahead and target the main branch. So to do that, we're going to do branches, and then we can provide a list of the branches we do want this workflow to run against. So if there's a pull request into my main branch, then this will run. One other thing we're going to do is we're going to use the paths property. And what this allows us to do is we can whitelist a set of files or blacklist a set of files that we only want this to run when there's a change in that particular folder or file. This is useful for projects like this where we have multiple subfolders and we may only want to run this workflow when it's targeted to the project we're working on. So as an example, if we didn't provide paths and I just modified a file in the cron example, and I opened a pull request, this would still trigger my workflow. When all of this code right here that we're doing is only applicable to the TypeScript project. So it doesn't make sense to go ahead and run this change on that particular folder. So what I'm going to do is I'm just going to provide the path to my project. So TypeScript project, and then I'm just going to use wildcard. And so basically what this does is if any file changes under this subfolder, then that will also be part of the criteria for having this workflow run. So then what I'm going to do is I'm going to go ahead and save my changes. I'm going to go ahead and push them up to repository. And then what I'm going to do is I'm going to go ahead and create a new branch to go ahead and test out our workflow to make sure this is working correctly. So what I'm going to do is I'm just going to go ahead and modify our README. And I'm just going to add a couple empty lines. I have test. And then I'm going to go ahead and create a new branch instead of committing it directly. And then I'm going to go ahead and open up pull request. So normally it would be much more descriptive and provide more details in a meaningful pull request, but this is just for our example. And so you'll see right away inside of our status, our pull request can be merged and there's no CI processes running. And the reason for that is because I modified the README, that file doesn't exist inside this TypeScript project subfolder. So it doesn't want to run those changes. So what I'm going to do is I'm going to go ahead and close the pull request. I'm going to go ahead and go into our TypeScript project. And then what I'm going to do is I'm going to edit that README by adding a few lines. Same thing, I'm just going to do test, and I'm going to do a pull request. And so now what should happen is the CI should detect that the change was within that subfolder and then kick off that workflow. So you'll see now it's running our pull request workflow and it's waiting for that status to be reported. So we'll go ahead and we'll just wait a second and we'll let that complete. All right, so we'll see that our workflow was successful. So if we go ahead and take a peek at the Actions tab, you'll see that here's our pull request called test. There's the branch that we're opening the pull request from. And if we take a peek, you'll see that it has our pull request job and it ran all of our steps. And so this is an example of when it was successful. And so what we can do is I'm going to go ahead and do another pull request, and I'm going to show an example of where it fails. So what we'll do is we'll go into our main.ts file, and I'm just going to go ahead and break one of the linting rules that we have. So I'm going to get rid of that semicolon and do another test. Open our pull request. And same thing, it should detect a change because it's running that file within that subfolder and it's pointing to the main branch. So we'll go ahead and let this check run, and then we'll check the status. All right, so you'll see that our workflow has finished and it's now failing. And so what we can use, we click on details. What it'll do is it's going to show us our job, and it's going to show us at what step in our workflow we failed. And so you'll see we failed at our linting step. And so what happens is when we fail, GitHub will automatically skip the rest of the steps that you've defined and immediately go to do the cleanup process and exit out. This is, of course, if you don't have additional steps that catch the errors or run always. And so this was an example of how we can use that to now see that we've introduced bad code into the project, and we could have additional branch protection rules to prevent this code from being merged, and just by having the CI run this step for us. So one other thing I want to take a look at is another thing we introduced the caching for our NPM modules. And so what I'm going to do is I'm going to go into our test example. And so if we go into our workflow, if we go into the setup node 16, you'll see here that in this particular example, we found cache, and so what it'll do is it's going to go ahead and load our cache dependencies for us, and then so that way the install process should be faster. Versus if we take a look at the first time our pull request example ran, so this case here, go into setup node, you'll see no NPM cache was found. And so this is going to do a fresh pull. So it's going to download any dependencies and then install them on the runner. And so at that point, they'll get cached. And so this is helpful if your project has a lot of dependencies, because you can use that caching to your advantage. All right, for our next workflow, we're going to take a look at a merge example. And basically what this is, we're going to listen for the trigger event of push. So anytime there's a webhook event of code being pushed to your repository, we would run this workflow. And the idea here is anytime code is pushed or merged into your main branch, one of the things you might want to do is tag your code and possibly release a new version of your code. So if it's like an NPM package, you could bundle up a new version, push it up to the NPM repo, NPM repository, and then it would be available for everyone to download and consume. So in our particular example, what we're going to do is we're going to target our main branch. So anytime there's code pushed to this branch, we're going to go ahead and take our TypeScript project example, and we're going to release a new version of our project. And we're going to go ahead and tag our code with that new version. And so with our node projects, one of the things we have in here is we have a version number on our package JSON. And so when we version, so we run this particular npm command, what it'll do is it'll bump up our version number. So it'll go ahead and patch it and do like a 6, 7, so on and so forth as we keep adding new versions. And once we do that, we're going to go ahead and tag our commit, and then that way we have a release on GitHub, a GitHub tag that'll reference this particular commit. So to get started, what we'll do is we're going to add a new workflow. So we're going to come up to our workflows folder. I'm just going to call it merge YAML. And to get us started, we're just going to go ahead and copy our pull request example. Let's go ahead and update the name of our workflow. It's a new merge example. And we'll also update our job name. Let's call this merge. All right, and then so next what we're going to do is we're going to go ahead and update our triggers. So instead of running on pull requests, we're going to go ahead and run on push. And so, like I said, push is the event that will, push is the GitHub event that will fire when new code, a new commit is added to your repository. So anytime we push new code up to your repo. So this will be anytime we push code directly to our branch. This will be anytime we merge a pull request, because a new commit will be created to push the code into that branch. And that's when this event will fire. So for our example, we're still going to target our main branch. So anytime there's new code introduced here, this workflow will run. And as long as it's code tied to the TypeScript project subfolder. Then for the most part, the rest of our steps will remain the same. So we're going to check out the repo, set up node, run yarn, install our dependencies, do our lint, our build, and our test. And then that way, if something failed here, or for some reason the CI and the pull request didn't run, these steps will catch that code. And then what we're going to do is we're going to introduce a few new steps. And so we're going to go ahead and run our version command to go ahead and bump the version on our project. So to do that, what we're going to do is we're going to do run We'll do yarn version, and we're just going to do a patch for what we're targeting, and then we're going to go ahead and provide a message. So this will be the commit message for when we add this change. So I'm just going to do bump version to %s. And what that'll do is it'll add the version number dynamically when the patch command runs as part of the output. So then, when we run this patch command, what it's going to do, like I said, it's going to create a new change. It's going to add it and commit it to our local branch. And so what we need to do now is we need to take this and push it up to GitHub. So to do that, we'll do a get push. So it's going to push our local changes from the CI. And then we want to go ahead and also push our tags. And so part of the version command is it'll go ahead and automatically create our git tag for our particular commit. So we're just going to go ahead and do git push follow tags. All right, so if we take a look at our package.json in our TypeScript project folder real quick, when we run the yarn version command, there's a few things that's going to happen. The first thing is a yarn version is going to bump our version number depending on the properties that we pass to it, so the configuration. So we only target a patch. So what that'll do is it's going to bump this 5 to a 6. And then once that's done, it's also going to go ahead and run our version script. So this is not mandatory, but if you have it, yarn version will go ahead and run this and then run that command for us. And so in our example here, what we're doing is we're using auto changelog to create a changelog for us, and then we're going to go ahead and add that as part of our commit. And so we just need to go ahead and push those changes that are local on the CI to GitHub. And the last thing we need to do is we need to actually configure Git to provide a user that will be doing the pushing of the code here. So to do that, we just need to run git config. So we'll do run, we'll do git config, we're going to do user.email. So I'm just going to use my email. You want to replace this with yours. And then we want to go ahead and just provide the username. So we're going to do run git config the user.name, and we're just going to do at GitHub CI. All right, and so for the password, we don't provide anything because one of the things that's available to our CI process is a GitHub token that's tied to the scope of this workflow, and that token will have permissions to push to this repository as long as there's no Git protection, if there's no protection on the branches. So currently we don't have that set up, so we go ahead and push directly to the branch. All right, and before we push our code, we need to make one more change. We actually need to provide a value for our node version. So by default, our setup node action, if it does not find a node version specified here, it'll fall back to using the default one from the path in the container that's running. And generally, this will be the node LTS version, which happens to be node 16 at this time. But it's always best practice to go ahead and provide this version, so we're always running the version of node that we're expecting. So what we'll do, let's pop open our pull request YAML. Let's just copy that value, and we will add it to our configuration. We'll save, and we'll go ahead and push our changes, and we can test our code. All right, so if we come to our repo, what we'll want to do is we're going to want to trigger our workflow. And so to do that, what we're going to do is I'm going to go ahead and come into our TypeScript project. I'm going to go ahead and update our README. And so I'm just going to take away a few of these empty new lines. And leave the commit message. I'm going to commit directly to our main branch. And so by doing that, this should fire off the event for the push event. And so now if we come to our actions, we should see that our workflow has been triggered. So we updated our README. And so now our merge process is running. So we can go ahead and take a look at the changes and make sure everything ran correctly. All right, so now that our workflow is completed, it should be successful. So we're going to take a look at our merge workflow. We'll see it runs all the commands from our one before with our new steps. So we configure our GitHub user and username. We run our patch command. So in this particular workflow, my version was at 8, and so we got bumped to 9. And then it ran my version command, so I updated my change log, and then went ahead and pushed my changes, and it went ahead and pushed my tags. So if I look at my GitHub tags, I should see a version 00.9. So that'll be one thing to keep in mind, is whatever version your package JSON is at, it should be at the next version. So if I go to code, first thing I'm going to do is I'm going to take a look at the commits. And so you see right here in the commits, we went ahead and bumped version to 9. And if I take a look, you'll see here, this is the auto change log that I mentioned, and went ahead and added this change as well. And then in the package JSON, it bumped my version. And then if I go into my tags, you'll see we have the version 00.9 pointing to that particular commit. All right, for our next workflow, what we're going to do is we're going to extend our merge workflow, and we're actually going to publish a package to the GitHub NPM package repository. So to do this, there is an example project, this tsconfig project subfolder inside the repository. If you're not familiar, tsconfig is a configuration file that's used for TypeScript, and it is given to the TSC compiler when it's compiling your code and converting it over to JavaScript. And generally, this file will just be a JSON file with your options, and what this project is it exports this out as an object, as an NPM package, so that way we can reuse this configuration across multiple projects. So to get started, let's go ahead and switch over to our code. And the first thing we're going to go ahead and do is we're going to go ahead and create a new workflow file. So we're going to call this publish package.yaml. What we'll do, like I said, we're going to extend our merge YAML, so let's just copy all of that code over here. We'll update our name, so we'll do publish GitHub NPM package. We'll change our project directory, so we'll do tsconfig project. We will also do that for our working directory. And for our caching, our particular project doesn't actually have any dependencies, so there's nothing to install. So let's go ahead and get rid of that cache. And then what we'll do is we're going to go ahead and clean up some of these scripts. So if we just take a quick peek inside our project, you'll see that most of these scripts do not exist. And the reason for that is because we're just exporting out this JSON file. There's no building, compiling, testing, linting, anything that really needs to be done on the project. We're just taking this file and exporting it out. So what we'll do is we're just going to go ahead and set up Node. We don't need to do install test or any of that, so let's get rid of that. We do want to go ahead and bump our package version. So if there is a new release of our configuration, we do want this to get bumped up. So we will want to use the version with our message, and we'll also want to commit it to the repo. And then what we'll need to do is we actually need to add the commands for publishing to GitHub. So what we'll do is we're going to add a new step. We're going to call it publish to GitHub for the name. When we run, we're going to run a few commands. So we'll do npm config set registry. And we're going to set this to the GitHub NPM package repository. And so generally, when you're working with NPM, the default registry is the NPM registry. And so if you want to point to a different one, such as GitHub's, a self-hosted one, or any of the various other ones, you actually have to update your configuration for NPM to point to that, so that we can pull packages from there. So then, because we updated our configuration there, generally when you work with the registry, when you want to publish a new version of a package or publish a version of a package, you have to provide your credentials to authenticate against the registry. So this is something you'll typically do with NPM. You also do with GitHub. So we'll need to provide our access token to do this. Luckily, out of the box, our GitHub Workflows, as I said, has a particular secret that is available during the workflow running that has this permission to do so. We just need to tell NPM how to use that token. We can do that by doing npm set. And now we just need to point to our registry. So the npm package github.com, do / and then auth token. And then we just need to provide the secret, our environment variable that's available. So it's env.node auth token. And then we're going to want to go ahead and run our script for publishing our package. So if you go into our package JSON, one of our scripts is published to GitHub. And so it just goes ahead and publishes to the GitHub package repository. So we'll do npm run publish GitHub. And then we just need to provide this environment variable. So when we do env.environment variable name, that needs to be available to the particular step that's running, and it needs to reference something. So currently this will be undefined. So if we try to run this will fail. And so what we can do is we can provide environment variables to a particular step, or if it's something that's reused across multiple steps, you can also add it outside your jobs as a global variable, and it'll be available to all steps. Since this step is the only one that needs this variable, we're going to add it just here. And so basically this takes the environment variable name that we want to set, and then the value that we want to pass into the environment. And so this will be the actual secret that is set by this workflow. And so it's just secrets.github token that's available to this workflow when it runs. And with this little change, that should be all we need for our workflow. So let's go ahead and save. And we need to make a few modifications to our package JSON file. So generally when you publish your NPM packages on GitHub or like NPM, they will have a scope that's tied to your username. And so this is right now pointed to the main repository for where the code's hosted. We're actually going to want to update this to reflect our GitHub username. So in my case, this will be Scott Westover, and you just want to replace this with your actual username for GitHub. And then the other piece we'll want to do is update this repository URL. And so when we publish our GitHub NPM package, it's going to use this repository URL to publish the package to that repo. And so generally, this will be your username as well. And when you fork the repo, it should still have the GitHub Actions Basics course name. And just to do a little bit of cleanup, I'm also going to go ahead and do it with the bugs and the home page just to keep it consistent. All right. Before we push our code, let's just go ahead and update our job name as well. So we're just going to change this to npm publish. All right, so now if we save and push our code, we should be able to test our changes. All right, so if we switch back to the GitHub UI, what we'll do is we'll come to Actions. We should see our new workflow for publishing our GitHub NPM package. And so our workflow should run because it will run when code is merged. So we're going to take a look. We'll see the publish workflow. We'll see we went ahead, bumped our version, and then what we're really interested in is publish to GitHub here. So you'll see we set our registry to the GitHub package repository. We go ahead and set up our configuration, and then you'll see that we have our details from NPM. So we see our package, our version, and it'll say it was published to NPM, and this plus icon means it should be successful. So ideally, what we should see in our code base is we should see our new package. So if we come back to the main page, you'll see over here on the right-hand side, I have this tsconfig example package. And so now, if I set up my code base to use GitHub NPM packages, I can go ahead and install this package and use it. So one thing to note is if you don't see this on the right-hand side, if you go up to your settings over here, you can have this option to enable and disable packages, and it'll show up. Also, if you go to your repo name and then go to packages as part of the URL, you'll see the packages that are tied to that particular repository. So the next topic we're going to take a look at is using secrets in our GitHub workflows. So far in our workflows, we've not had a need for an additional sensitive value, but there's plenty of use cases for where you might need to provide a sensitive API key or access token to your workflow file so you can execute some type of action. And luckily, out of the box, GitHub Actions supports this. And to do that, basically what we're going to do is go to your settings in your repository. Under your options, in the security tab, there's a secrets section, and you can add to your actions additional environment secrets that you want to be available to your workflows. So there's a variety of ways that you can do this. You can set it up for an environment basis, so you could target like your dev, staging, production environment. You could set up a global one that's just access to your repository across all environments. If you're part of an organization, you can set up a organization secret and allow repos to access it. And so there's a lot of configurations options available to you. So for this course, we're just going to focus on repository secrets. So the nice thing about repository secrets is they only apply to this repository. So if I create it here and I go to another one of my repos, it won't be available. And so to create a secret, you just would want to provide a meaningful name for your secret. So basically, this will be the environment variable, the secret environment variable that's available to you in your workflow file. So just as an example, I'm just going to call this test secret. And then I'm just going to go ahead and put in foo. And so here you provide your sensitive value. Go ahead and click on add secret. We'll see that our screen's been updated. We now have a new repository secret called test secret. And so now in our workflow files, we have the option to pull this and use that in our workflow. So to see an example, what we'll do is let's switch over to our code. So let's go ahead and make a new workflow file. I'm just going to call this secrets.yaml. And then what we'll do is we'll just go to our shared actions YAML file. Let's just copy that block of code. We'll update our workflow name. So we're just going to do secret example. And we'll run our workflow dispatch. For our steps, we don't need to check out our repo because we're just testing our secret. So we're just going to change our step name to test secret. And then we're going to go ahead and run a set of steps. Then we're just going to run some code. What we'll do echo mast secret, and then what we'll do is we'll do echo secrets dot test secret. All right, so out of the box, GitHub Actions will go ahead and mask if you try to access your secret values and try to print them to the console. So it's just an additional security mechanism that's in place to help protect you from leaking your secrets. So what we're going to do is to validate our secrets coming through, and just for educational purposes, we're going to manipulate the string a little bit so that way we can actually print out the value. So it's definitely not recommended that you do this for any of your so it's definitely recommend so I definitely don't recommend doing this for any of your actual projects, and this is just for educational purposes only. So we'll do secret, and so what we'll do is we'll go ahead and access our secret again. And then what we'll do is we'll take our string and we're just going to modify it a little bit by adding some spaces. Oh, and one last thing we want to do before we commit our code is just update our job name. So let's do test secret. Now if we go ahead and save and commit our code, let's go ahead and come to the GitHub UI. Let's go to our secrets example workflow, and let's go ahead and manually run it. And so we'll just let the job queue up and execute, and we'll take a look at the results. All right, so if we go into our test secret job, and we'll go ahead and view the test secret. So you'll see here, if we try to echo out our secret, by default, it does get masked. And like I said, because of the manipulation, we can see the value. So we'll see that our foo value was passed through, and we can use that secret. So with that, this brings this mini course on an introduction to GitHub Actions and Workflows to an end. So in summary, in this course, we did a brief introduction to GitHub Actions and Workflows and what these terms mean and why they are important to you if you use GitHub. We talked about the GitHub Marketplace and how you can find and share reusable components or GitHub Actions through the Marketplace, so that way you can reuse them in your workflows. We went over the core concepts of the GitHub Actions. So we talked about like what workflows are, events, how events are tied to our triggers, jobs, actions, etc. We then started to create some example workflows by doing a simple hello world one where you could see how the workflow will be detected and ran and how you can run this manually. We then started looking at some more examples you probably use on a day-to-day basis. One of these being like a cron or integration type job, pull request for running linting, building, and testing your code, push version where you could tag version your code, and then you could publish your code as an NPM package. So I just want to say a big thank you for taking the time to watch this course, and I hope you found it helpful. If you have any questions, comments, or suggestions on further topics that you would like to see covered, please feel free to leave a comment below or open an issue or discussion over at the GitHub repository.